So far, we have learned 3 different ways to solve systems of equations. What are our 3 different ways? Substitution, addition, and graphing. Those are our 3 ways. Today we're going to learn a 4th way. And the 4th way is called Cramer's rule. Let's do that a second. Before we can talk about Cramer's rule, we've got to talk about a matrix for a few minutes. A matrix. Not the matrix, rather a matrix. A matrix. In a math class, what is a matrix? Anybody ever heard the word matrix before, other than the movie? No, it's really not very complex. It does kind of rhyme with complex. Yeah, it's very similar to a spreadsheet. A matrix, this is an array of data values. Now, for our purposes, data values are going to be numbers, but an array could have letters in it or words in it or whatever. So a matrix is something that looks like this. Looks a lot like a spreadsheet. So you might have 4 and 2 and -1 and 9. There's a matrix. That matrix would be called a 2x2 matrix. Why would you call that a 2x2 matrix? Because it has 2 rows going down and 2 columns going across. So we call this a 2x2 matrix. This is a 2x2 matrix. So you're right, a matrix looks an awful lot like a spreadsheet. In a spreadsheet, you store things like that. In a spreadsheet, typically the columns are labeled A, B, C, D, E, and the rows are numbered 1, 2, 3, 4, 5, so on and so forth. If you have ever used a spreadsheet, they usually labeled that way. We tend to label things using only numbers. So we call this position right here, we call this one the first row in the first column. So we call this one position 1, 1. First row, first column. This one we call position 1, 2. First row, second column. So on and so forth. This is 2, 1, and 2, 2. Alright, so a square matrix, like this one, this is square, it's 2x2. What else would be a square matrix? 3x3, 4x4. We're only going to deal with 2x2 for this section, so we'll only go for 2x2. A square matrix has an important number associated with it called the determinant. This number determinant is good for a lot of things, but for our purposes today, we're going to use this thing called determinant as a way to solve systems of equations using Cramer's rule. All right, so here's the definition. Definition of determinant for 2x2 matrices. So if I have a matrix and I have A, B, C, and D, a 2x2 matrix. Generally, we don't write out the word determinant. We'd be a little bit lazy. We call it DET. So that symbol stands for determinant of that 2x2 matrix. To find the determinant, you multiply A times D. So you multiply this diagonal, A times D, and then minus, you multiply the other diagonal, C times D. So it's always this way gets the positive, that way gets the negative. Always that way. So you start in the upper left, multiply diagonally, that one's positive. Go to the lower left, multiply diagonally, that one gets a negative. So, if I have this matrix, 4, 2, -1, 9, What's the determinant of that matrix? 38. How'd you get 38? 4 times 9 is 36, minus negative 1 times 2 is negative 2. 36 plus 32 is 38. So that would be called the determinant of that matrix. Pretty simple to compute. All right, one more of these. How about the determinant of the matrix? Make up some numbers for me. 7, 2, 4. 96. Since I heard 6 and 9, I'll put them together and make 96. So the determinant would be, I multiply diagonally. I take 7 times 96 minus 4 times 2. And I'm probably going to grab my calculator for that one because 7 times 96, that's somewhat large. I don't know what that is off the top of my head. 672 minus 8. 672 minus 8, which sounds like 664. All right, so now we're ready for Cramer's rule. Now that we know what determinants are. Let's say we have a system of equations. And I'll just make up a nice system of equations here. How about 5x minus 3y equals 12, and minus 2x plus 4y is negative 7. Could you solve that system by graphing? Yeah, you'd probably need to use your calculator because it wouldn't be a very easy one. Could you solve that equation by substitution?
Yeah.
Yeah, but it's not really an easy one to do by substitution, is it? How come it's not really an easy one to do by substitution? Yeah, all of the variables have a coefficient that's not 1, don't they? So eventually, no matter what letter I want to get alone, eventually I'm going to have to divide by something, and that's going to give me fractions, and that's a pain in the neck to deal with. Don't want to. Could you solve this one by addition? Yeah, that's probably your best way. So if I were to do it by addition, I might multiply this top equation by 2, and that would give me a 10x. Multiply this one by 5 to get a negative 10x. Or I could multiply by 4 and 3 and make the y's go away. That's correct. So I think if I had to solve this one, I think addition would be my best choice. But here's an alternative, and the alternative is Cramer's rule. To do Cramer's rule, you make 3 matrices. The first one is just called D. And the matrix D is simply the coefficient matrix. So what I mean by the coefficient matrix is, it's these numbers over here. So D has 5, negative 3, negative 2, and 4. So there's D. D is just the coefficients, it's the numbers on the left-hand side. The second matrix is called D sub x. For D sub x, you take these numbers over here, the 12 and the negative 7, and you put them in place of the x numbers from your original D matrix. So instead of having 5 and negative 2, I'm going to put 12 and negative 7. So 12 and negative 7 go there. What goes on the right? Leave it exactly like it was in the D matrix, negative 3 and 4. So for dx, you take these numbers and you put them in the x spots. And then your third matrix is dy. And I bet you can guess what dy is. It's the same thing as dx, except what do you do with the 12 and the negative 7? They go into the right, they go into the y spot. So I put the 12 and the negative 7 over here, and then back in the x spots, or the original x's, 5 and negative 2. All right, so you build those 3 matrices. Not too hard so far. Here's the answer. To find x, I take the determinant of the matrix dx and I divide it by the determinant of matrix D. So, what's the determinant of matrix dx? Well, you don't have to do it all at once. Tell me what you would do. 69? Alright, and so what you did is you took 12 times 4, and that was 48, minus, I think you made a mistake trying to do it all in your head maybe, because negative 7 times negative 3 is 21, but it already had a minus in front of it, so it's 48 minus 21, which is what? So it's going to have 27 on top. And then down on bottom, I go to my original D matrix. That's going to be 5 times 4 is 20, minus negative 2 times negative 3 is 6. I agree with you, 14. 27 over 14, does that reduce at all? No? No. All right, so we leave it. All right, how do you find y? You do exactly the same thing except you use dy. That is correct. So dy is the determinant of dy divided by the determinant of d. And the nice thing is, I already know what the determinant of d is. What's the determinant of d? 14. I already did that. I don't have to do it again. I just put 14 right down on the bottom there. 5 times negative 7 is negative 35, minus negative 2 times 12 is negative 24. But a minus and a minus makes a plus, so that's plus 24. So negative 35 plus 24, negative 11 over 14. Too many negatives? Too many negatives. All right, so what's kind of cool about Cramer's rule? Anything? There's no algebra at all. In fact, it's all arithmetic, isn't it? It's multiply and subtract is all you're doing. There's no algebra at all. I think that's really cool. Anything else? Pretty quickly you can figure out both. Yep. That's a great question. So I would say the advantages of using Cramer's rule are, number one, I don't have to do any algebra at all. All I have to do is arithmetic. The second advantage for me, I would say, is using the other techniques. If my answer turned out to be a fraction like it did here, I would have to take that fraction and plug it in and then solve. So I would have to do a bunch of algebra and arithmetic using fractions even. Where with Cramer's rule, if your answers come out to be fractions, they come out to be fractions. Never once anywhere did I have to add, subtract, multiply, or divide a fraction. They just came out that way and I live with them. Where using the other techniques, I would have to plug a number in, which means I'd have to plug in a fraction, which means I'd have to do some adding, subtracting, multiplying, and dividing with fractions. That can be a pain in the neck. The only thing you should do, correct, you should simplify if possible. This one didn't simplify, so we didn't have to even do that. Okay? Now, the downside to Cramer's rule is in the very next section, we're going to talk about how to solve using 3 equations with 3 variables. So for Cramer's rule, we'll have an x and a y and a z and then some numbers. We would need a d, a dx, a dy, and a dz. Unfortunately, finding the determinant for a 3x3 matrix is much harder than a 2x2. So Cramer's rule is really mostly only a good technique when you have 2 equations with 2 variables. If you have 3 equations with 3 variables or 4 and 4, finding determinants gets very hard, very cumbersome. So it becomes much more quicker to do it using other techniques. It can be done. In fact, section 5.8 in your book is using Kramer's rule with 3x3 systems. We chose not to cover that one just because it's a pain in the neck. But it can be done. With technology today, with a graphing calculator, there is a way to use your calculator to compute determinants. It's not so bad, but to do it by hand is just miserable. So we don't do it very often. Questions? Should we do one more? Yeah. No three-dimensional ones today. 3x2x2? 10-dimensional one? Not so good at 10 dimensions. All right, give me some numbers. Make up some numbers for me. 7x minus 9y equals, what is it? 42. Second equation. 9x plus 7y equals 24. All right. Now, to use Kramer's rule, you do have to write your equations this way. If your equation is y equals mx plus b form, then you've got to move it over. You've got to have the x's and y's on one side. So there could be a very small amount of algebra you have to do. You have to write your equations this way. You need the x's lining up, the y's lining up, and then the numbers. If it's y equals mx plus b, then you should probably do substitution because that makes a lot more sense and it's probably going to be easier anyway. You're right. So, all right. 3 matrices. D. What's D? Seven, negative 9, 9, and 7. What's dx? 42, 24 go on the left. And minus 9 and 7 go on the right. And finally, dy. 7 and 9 on the left. 42 and 24 on the right. All right. So, x. To find x, I take the determinant of dx, and I divide by the determinant of d. dx, that's going to be 42 times 7 minus 24 times negative 9, but that's going to be a negative, and I already have a negative, so that's going to make a positive, plus 24 times 9. Divided by, d down on bottom has 7 times 7, that's 49. Minus, but then I see I have another minus here, so that's going to make a plus, 81. All right, so I probably grab my calculator at this point. 42 times 7 plus 24 times 9. You have 510 total? 510 on top. And how about on bottom? 130. Those are easier to add together. Yes, 130? 130. So that's 51 over 13. I can definitely cancel 10 out of top and bottom. So again, this is one of the advantages of Kramer's rule. The fact that I have a fraction for my answer doesn't bother me because I don't have to plug it in anywhere. I just get to go right ahead and go to y. So y is the determinant of dy divided by the determinant of d. And that's going to be 7 times 24 minus 9 times 42. And then it's going to be divided by 130. Make sure you use your denominator before you reduce every 130. All right, so what's that on top? Grab your calculator. You get negative 210. So again, I can reduce by a 10. That's negative 21 over 13. Questions on that? One that contains 5% alcohol and another with 11% alcohol. How many gallons of each must be mixed to make 500 gallons of gasohol containing 9.5% alcohol? All right, so we've seen problems like this before where we have mixture problems. We need to set up a system of equations, and that says use Cramer's rule. All right, so what do I do? Do what? Mix it all together and hope, okay? What's X and what's Y? All right, so we need two variables. You're going to call them X and Y. I like your choices. So X is amount of first, and Y equals amount of second. So when I say amount, I mean number of gallons. X is the number of gallons of the first mixture. Y is the number of gallons of the second mixture. And then you're 100% correct. X plus Y would have to be 500. Because I'm mixing these two things together. So the amount of the first one plus the amount of the second one, when I get all done, I need to have 500 gallons. So there's one equation, but I have two variables, so I need another equation. %5 of X and 11% of Y is 0.095. That's almost correct. 9.5% of, percent always needs to multiply something. If you just write 0.095, you should know you made a mistake. Percent always needs to multiply something. The percent multiplies the amount of total liquid that we have. So I need to take 0.05 times X, that's how much alcohol is in the first mixture, plus 0.11Y, that's how much alcohol is in the second mixture. And when I get all done, I need 500 gallons, and I need it to be 9.5% alcohol. That's a very common mistake. People just put the 0.095 over here. It's always going to be 0.095 times something. Percents always have to multiply something. All right, so quickly, grabbing my calculator here, what's 0.095 times 500? 47.5? All right. So now the directions say solve using Cramer's rule. If the directions just said solve and do it any way in the whole wide world that you like, I would probably use substitution for this one, because I can very, very easily get the X or the Y all by itself. And that's something that, on the test, when you take your test next week, I am going to give you some options. Sometimes I will specifically say solve using Cramer's rule, because I want to make sure you know how to use Cramer's rule. But in general, for a word problem like this, I would just say solve. And then you're going to have the freedom to solve any way that you really want to solve it. You can use any technique you want. I personally would use substitution. I think that's the best way for this problem. But I'm going to follow the directions. Do we want to leave these decimals here?
No.
Multiply by 100, because I got to move the decimal two places, don't I? Would Cramer's rule work all right with those decimals?
Yeah.
It really would, because we would just grab our calculator and use our calculator to multiply and subtract anyway. But, let's get rid of them. So that'll be 5x plus 11y is 4,750. All right, get rid of the decimals, makes life a little bit easier for us, I guess. All right, so my matrices, D is 1, 1, 5, 11. dx is, for dx, I'm going to have 500 and 4,750 on the left side, and 1 and 11 on the right. And then finally dy will have the 500 and the 4,750 on the right, and 1 and 5 on the left. X is, to find x, I put the dx on top, so that's going to be 500 times 11 minus 4,750 times 1 divided by, d goes on bottom, that's going to be 11 minus 5. $750 over 6. You want to leave it like that, or does it reduce, or do you want to give me a decimal? 125 exactly? Okay. 125 exactly. Okay. That's nice. Okay. And then finally, y. What'd you get? How did you get 375 so fast? Yeah, so now the question becomes, would you really do determinant of dy divided by d, or would you just take the 125 and plug it in and solve? Okay, so on the test, I guess, on the test, if I said use Cramer's rule, then I would expect you to use Cramer's rule for both. If this were a word problem, and I just said solve any way you want to solve it, and you did part Cramer's rule and part substitution, that'd be fine with me. All right, so let's just finish it out, although we know what the answer is going to be. So dy would have 1 times 4750 minus 5 times 500 over 6. And we grabbed our calculator, we got 375. I'm not happy to do it. 2,250 over 6, which is 375. All right, then this last problem. Might not have time to finish this one. We'll get it started. For the electrical circuit shown below, Kirchhoff's current and voltage laws can be used to set up a system of 3 equations and 3 unknowns. Uh-oh, too many variables. So Kirchhoff's current law, as opposed to his previous law, this is the current one, gives I1 equals I2 plus I3. So you guys don't laugh at my bad math jokes. That's okay. And then we have Kirchhoff's voltage law says 9 equals 3I1 plus 5I2, and 9 equals 3I1 plus 6I3. So, what does it mean when it says use Kirchhoff's current law to reduce this to a 2-dimensional systems of equations, then use Cramer's law to solve? Notice what we have. We have 3 equations this time, don't we? And we have 3 variables, I1, I2, I3. This one only has I1 and I2. This one has I1 and I3. Any ideas? Correct. What we're going to do is we're going to take this equation right here, I1 equals I2 plus I3. I'm going to plug that in right there, and I'm going to plug it in right there. It is, but that's the first part. It says use Kirchhoff's current law to reduce this to a 2-dimensional system. So first we use substitution, and then that'll give us 2 equations with 2 variables, and then we can use Cramer's rule. All right, so plugging those in, I get 9 equals 3 times I2 plus I3 plus 5I2. And I'm going to go ahead and simplify this. That's 3I2 plus 3I3 plus 5I2. So simplified down, that's 8I2 plus 3I3. And then the second one, I have 9 equals 3 times I2 plus I3 again, plus 6I3. And I'm going to skip some steps and just tell you what you get when you simplify it. Same thing, distribute, add your like terms. You're going to get 3I2 plus 9I3. So what we've done is we started with 3 equations containing 3 variables, we did a little bit of substitution to reduce it, so now we have two equations, and they only have two variables each, I2 and I3. So in a way, we eliminated the I1, we got rid of it. Okay? So I'm going to stop there. I think from there, this one's pretty straightforward. You would go ahead and you would use Cramer's rule to solve it, so you set up the determinants, do the arithmetic, work it out. Questions on that one?